Okay, so let us just start our discussion, continuing from the BFS algorithm what we were doing yesterday. Now here we would see an application of that algorithm. So here I have a question that states you are given an m cross n grid where each cell represents 0, 1 and 2, 0 referring to an empty cell, 1 referring to a fresh orange and 2 referring to a rotten orange. Basically, you can say that you have been given a tray of oranges, like you can see here. You are given with an tray of oranges. Therein you have a fresh count of oranges as well as empty cells as well as rotten ones. So let's read the question further. Every minute, any fresh orange that is 4 directionally adjacent to a rotten orange becomes rotten. Okay, so it is saying that if I have a rotten orange here, so it can rot the fresh orange lying in the 4 directionally adjacent like this. Like if there is an orange present here or here or here or here, it can rot all these 4 oranges within a single minute. That is saying the question. So what we are required to find, return the minimum number of minutes that must elapse until no cell has a fresh orange. Okay, or return -1 if it is impossible. Okay, so let us just observe the given example carefully. We have been given a 2D array where it represents 2, 1, 1, 2 representing a rotten orange, 1, 1 representing a fresh orange, as well as we have zeros representing empty cells. So let me just quickly draw the tray here. So we are given with a tray of oranges having bad oranges or the rotten oranges as well as the fresh oranges, and I have empty cells also. So I can say that for the minute 0, as it is written here, I think so, yeah, minute 0, minute 1, minute 2, minute 3 and finally minute 4. So it is basically saying that if you are rotten here, so you can rot this fresh orange and this fresh orange. So in the first minute you get 3 rotten oranges, including the one which was previously rotten by the given question. So I can say that for the minute 1, within 1 minute I would get a tray like, wait a second, I would get a tray like this and this. So I would rot this orange as well as this orange, since they are lying in my adjacency right as well as adjacency down. It cannot rot this or this since it is in a boundary. Okay, you might be understanding this. So now I have minute 1 configuration like this. So what about minute 2 configuration? A minute 2 configuration would look something like, see, I have oranges like spreading here, rotting has been done till here. So this orange can rot this orange, further this orange can rot this orange. Okay, so in minute 2 I get this kind of configuration. What would be about minute 3? You might have guessed correctly, I hope so. Yeah, the cell with 2, 1 basically would get rot here. So all these are rotten ones, and so this rotten one would rot this. So I get this configuration after my 3rd minute elapsed. Now finally, when I would rot it further for a minute, when I would let it to rot for a 4th minute, I would get a complete tray being rotten. So I have to return 4 as my answer. Okay, so this is the basically question demanding. So can you just imagine where it would be the case when we have to return -1 as our answer? Yeah, you might be thinking about diagonally. Basically, if I have a tray like this and I have an orange here and I have fresh oranges like here, if I have a fresh oranges like here, so I cannot rot any of the oranges since they are lying diagonally adjacent. See, we are not given with the 8 adjacency like the question. Like, if I can just reframe the question by asking 8 directionally adjacent, so that I can go this side, as well as this side, as well as this side. Question might have asked for that also, but for the 4 directionally adjacent, we would restrict ourselves for not going to the directionally adjacent cell or the orange. So in this case, we would definitely return -1 as there are 2 oranges left fresh. Okay, so this is the basic idea, and we would implement using BFS search. As I have told you, it is a question of BFS search. For the BFS, we would keep a queue data structure, and within queue I would just mark the indices for the rotten oranges, for every rotten orange. See, I would just run 2 for loops, and I would have a count for the number of rotten oranges being represented by 2. Okay, so whenever I get 2, I would just insert that index both I, j to my queue, and I would count how many fresh oranges are there. Fresh when my cell would return 1, since 1 corresponds to a fresh orange. So in this way, I have to build a queue, and then I would proceed with the BFS algorithm as shown here. Like, this is our piece of code of implementation of the rotten oranges. Okay, since I haven't a time for writing the complete code, so I've just come up with the photos of that. So you can say here I've created a tuple class basically for storing I, j, the cells of the rotten oranges, and the time it would take. Okay, so let us just quickly see the main algorithm. See, I have declared a queue of type tuple for the class I have created with the 3 variables. Remember that it would be a very beneficial further. I have n, which is my row length, m as my column length, and I have a variable count fresh for accounting how many such fresh having the indices at I, j as 1. So I would just increase my counter, and within the 2 for loop I would check if the orange is my rotten, which is being represented by 2 here. I would just offer the queue the tuple of type I, j and 0. Okay, so I meaning my row element, j meaning my columns index, as well as 0 for my initial time configuration, since I am been inserting all the rotten oranges present at the initial configuration. Okay, so for that, time required would be 0 always, since it hasn't been rot for keeping it for a few minutes. It was given 2 hours within that question. Okay, so let us now continue with our algorithm. We would check, I have an edge case here. If count fresh equal to 0, means there are no fresh oranges. Thereby I can say it would have only rotten oranges or empty basket, or the empty tray you can say. So I would just return 0 that case. So no fresh oranges, so no time is needed. So next, what I will do here is a point of attention is required here at the point. So what I can say, I have to just like to see this 2 arrays, del row and del column. It is given that I have 2 arrays for row. It is given that I have -1, 0, 1, 0, and I have a column matrix. For that I have elements as 0, 1, 0, 0, 1, 0 and -1. Okay, So I have the column like a column array like this. So I can say if I have a rotten orange at my I comma j, okay, I've just found my rotten orange. So I have to check in my 4 direction ways, either up, either right, either down, or either left. So how can I go about that? See, if I am present at ith row and jth column, and if I want to go to my up, so what I can do is, see, if I have just something like this, and if I'm here and I have to search for above, so I have I as 1 and j as 1 here. So upper part would be represented by I minus 1. If I have array named ARR, I minus 1 and j as it is, since column is not shifting. So I can say that for up it would be representing like I minus 1 and j. Okay. Similarly for my down, since I am going downward, so I would increment it I plus 1 and j. Simple enough. Okay. So what about going rightwards? For going rightwards, in the same column, I am shifting in the same column. See, if I have a column like this, if I have rows like this and columns like this, you can say that I am just shifting to right and left. So I am not changing my ith index. So I would remain as it is, and I am shifting j to my right. So j here was suppose 1, so I would be having j here as 2. Okay. So I would having j plus 1, and similarly for my left index, I would be having I and j minus 1. Okay, so this is the condition I would be applying here. So I have just created 2 arrays for that, and now the process begins. See, until the queue is not empty, what I will do is I will just take queue.poll. Since I had a tuple class, so I would create a tuple variable, tuple object instance. So queue.poll, and I will just fetch all the materials containing in that tuple for the row t.I, since it was I, t.j corresponding to column, current time equal to t.time. Okay, so now I would run a for loop 4 times. Why 4 times? For checking up, right, down, left, total 4. So I would run a loop for 4 iterations wherein I would be modifying my row and column respectively. So n row means new row whatever the ith index I would having at the rotten orange found in that queue, plus the del row means I'm going upwards. Minus 1 means upwards. I am having I as row minus 1, so I'm going up. So my new row becomes I minus 1. Similarly, n call would corresponding to call plus del call. Del call for the first iteration is 0, so I plus 0, it would remain 0. So I'm going for the first iteration, I'm going up. Similarly, for the second iteration, when it would be v equal to 1, it would just check for 0 meaning I would remain in my same row, and for 1 it would just shift right, so it would check for right. Similarly down, and similarly left. So I would just create n row and n column indices, and I will check whether it is greater than or equal to 0 and is less than n. Why? To check whether the new row and new columns are contained in the boundary area only. They are not going out of bound. So that is why I would just check here if n row and n columns are greater than equal to 0, as well as it should be less than n at the same time, as well as n call. Similarly for n call, it would be greater than equal to 0 and must be less than m, and grid dot n row, it should be 1 corresponding to fresh count. If it would be fresh, now main 3 statements are here. If it is fresh, okay, so I would just enter the area of execution. So it is written that grid n row n call equal to 2. So assigning 2. So assigning 2 means rot the fresh orange. I am having. Okay, so basic idea was to rot all the oranges in minimum time. So I would rot wherever there is a fresh orange in my up, down, left, right. So I would rot first, and if it is rotten, I have to just definitely let it enter in my queue. You may call it a dustbin, queue meaning a dustbin here for our convenient, because the queue for the tuple class we have defined for the rotten oranges itself to check the breadth wise, like it will go, say, like if I have a rotten orange and I have upper side I have a fresh orange, so I would just rot, and I would check further for here 4 iterations. Here I would check also, and here I would check also, and suppose I've got a fresh orange, so I would rot, and again I would check it to the 4 directionally adjacent cells. So I would rot and let it enter queue, and count fresh would be minus minus. See, since I have rotten, I have rot one of my fresh orange. That's why I would just decrement count fresh by 1. Okay. So similarly, and I would have a trace of current time. I would just assign current time each time with the time, and while letting the new tuple enter in our queue, I would just increment the current time with 1. Okay, yeah, you would be getting the idea correctly why we would be adding the 1 here. So finally I have time equal to current time, and while there is no rotten oranges left in the queue, we would just come out of the loop, of the while loop, and there is still a edge case if count fresh is not equal to 0. The case it might arise for this case where the BFS would restrict up till here, and still we have a count fresh left. So it is saying that if count fresh is not equal to 0, meaning there are some oranges left fresh, return -1, and if not, then return time, the minimum time required to rot all oranges. So I hope so you might have understood the algorithm written carefully. You can check by executing the code as your homework. So let's just meet in our next class. Thank you.